Okay, let's look at sound. Sound is part of data, and particularly in AQA, it's a big part of the course of paper 1. When I'm talking in the classroom, the students are hearing me. I'm talking just in the classroom, just face to face. It's an analog sound wave. And in a recording studio, the singer is singing into the mic, and their voice is represented as an analog sound wave. But computers don't read analog sound waves. They want their sound stored as ones and zeros. So a process has to be gone through that converts that to ones and zeros. So this question here, 4.1, says describe why the sound must be converted to a digital format before it can be stored in a computer system. Computer systems store everything as ones and zeros. So computer systems use ones and zeros to store sound. They cannot recognize analog. Is the answer there for 2 marks. Okay, they cannot recognize an analog wave. I just might add that there. Okay, they want their sound stored as ones and zeros because basically they don't recognize an analog wave. 4.2. Now, apparently, this is the stat from AQA, only 25% of students who took this exam could actually do this question. So it's worth just going through that and looking. Actually, it's not that hard. It's a calculation. It's a formula you need to remember, and the formula you need is this. You need to memorize this for your exam. It's rate times resolution times seconds. Rate times res times secs. Okay, and that gives me in bits how much space I need to store my sound file. Okay, so I'm just going to write that out. It might be worth you writing that out if you've got a question like this, just so you remember. So my rate there is 2000, okay, multiplied by my resolution of 4, multiplied by the number of seconds, which is 5, okay, and that gives me 40,000, and that's actually in bits. So if I wrote that out, I'd get about 3 marks out of the 4 for that. Okay. The reason I won't get more is because I need it in bytes. Now you need to remember that there are 8 bits in a byte. So what I need to do then is divide that 40,000 by 8, and that gives me my grand total, my answer. 5,000 bytes. Okay, that's that calculation. Rate times res times secs. You need to memorize that. 4.3, there's a couple more questions to this. Not quite finished yet. And the two one markers. The sound engineer currently uses a sample resolution of 4 bits which enables sound to be stored as one of 16 different bit patterns. She wants to increase the number of bit patterns from 16 to 32. Shade 1 loss and show the minimum sample resolution in bits. Allow her to do this. Now, I've seen a lot of students go in and just, it's got to be 8, isn't it? And just shade that. That's not right. It's got to be the minimum. Yes, you can store it in 8, but that isn't what the questions ask you to do. It is actually 5 in this case. So what you need to think about is this. I'll just 1, 2, 4, 8, 16. Okay, she's storing the sound file in 4 bits, and this is 4 bits here. And I'm not going to draw these out, but you get the picture. You can represent 16 different bit patterns there. Okay, including the zeros. Up to 1111, that gives me 16. If she wants to increase the number of bit patterns from 16 to 32, so she wants 32 of that, all she needs is this extra bit here, and then she's got, if you ran through all that, she's got her 32 there, okay, including the zeros. So you only need 5 bits. It is the minimum. Right, 4.4. Shape one lozenge to show which of the following correctly states the effects of increasing the sample rates. The answer to that is D. And if we think about the sound wave here, okay, the way it works is in a recording studio, someone sings into a mic, that's picked up as electrical analog signal, that is then sampled at various points along the wave, and these numbers are converted into binary, and then you've got your sound file. If you increase the samples there, if I double that, or I'm not going to draw them more, but if I add more samples in there, what I'm going to do is increase the quality, because if I'm taking more samples, I've got a more realistic recording. I'm picking up the nuances of the sound wave, whereas I might not pick it up if I took less samples. But what I'm also going to be doing is increasing the file size as well. So if I take more samples, I need to store more data, therefore I increase the file size. So I don't really understand why only 25% of people got all these questions right. Hopefully that will change, and hopefully this has helped you.